Today, we're privileged to have David Erie, CTO of the Virginia Innovation Partnership Corporation, known as VIPC, and the Smart Community Testbed. Together, they're known as the Living Laboratories. And Khalil Yazdi from Crossroads Innovation Group, known as XIG. And Khalil will be leading the discussion today. Connected communities are only as strong as their critical infrastructure, which serves as the backbone for efficiency and sustainability. In this session, we delve into how IoT solutions are revolutionizing critical infrastructure, making communities safer, smarter, and more resilient. From optimizing energy consumption to implementing proactive maintenance measures, we'll be exploring the cutting-edge IoT technologies driving connectivity and sustainability in urban environments. Device Authority is proud to collaborate with both VIPC and XIG, amplifying the impact of our collective efforts towards advancing IoT solutions for connected communities. So with that, Khalil, I'd like to hand this session over to you. For the audience, please feel free to ask questions in the comment area, and we will probably get to those after the meeting if they aren't answered during the session. Thank you.
Thank you, John. Really appreciate it. Dave, welcome.
Thank you.
Really happy to be here again with you. I think we're going to have a fun conversation, so hopefully the audience will get something useful out of that. So just to do a little bit of introduction here, I am Chief Strategy Officer with Crossroads Innovation Group, working very closely with David on some of the projects that David has been able to champion and move forward, and as a partner to Device Authority in terms of bringing the kinds of technologies that Keyscaler will support and capabilities that Keyscaler supports to some of the challenging problems we're having in securing critical infrastructure. I also want to give special thanks to our host here. We're at the Caresoft offices in Reston, and I want to just really say thank you to Caresoft for giving us this opportunity to use their space. They are a good partner to both Crossroads and VIPC and Device Authority, and we look forward to working with them as we try to build out these capabilities and make them available to federal agencies, state, local government, and higher education. So we can dispense with the slides and really get into a conversation here. David, I want to start out by just getting a sense of, we talk about connected communities here, and I think it's great to level set on what we mean by both of those terms. So from the community perspective, could you talk a little bit about what it takes to put together the kinds of initiatives that you're spearheading with VIPC? Who are the major stakeholders? How do you get government and business, private and public sector working together? How's that working? How does that play? And
yeah, so I think the word community really embodies the concept that we're talking about here. Many people are familiar with like smart doorbells, video cameras or smart thermostats kind of thing. Those are individual capabilities. When we talk about community, it's really the set of services that we collectively use and take advantage of every day. And so that certainly includes governmental organizations, generally a local community, a local town government or county government. In some cases, maybe state government. In some cases, maybe a homeowners association could do some of these things. Certainly, it also includes the business community because those are very often the provider of a number of the services. And then it includes some of the specialized operators, if you will, in a community. So fire, emergency management system, sort of services, law enforcement.
Right.
And then critical infrastructure. So it can cover all of those.
I think there is a challenging overlap.
Yeah.
When you get into something like emergency medical services, hospitals have to be aligned with, which are private organizations, and for-profit organizations have to somehow be aligned with public services. If we get a flood or a wildfire, we're going to need a combination of resources from the commercial sector and the public sector to kind of deal with it in a meaningful way. and then in terms of communities, I heard you say, it's not just, the local quote unquote community or municipality, township or city. It's, the relationship between them and the state, and then at the federal level, because all of those entities play a role now in delivering services.
Well, I think if you look at the different kind of challenges that communities face, you mentioned flood or wildfire. It can range anything from, sort of a local incident, my neighbors, trespassing on my yard, if you will, to a national scale emergency, a major hurricane or a flood or something like that. And in each of those types of situations, the set of resources that are available to respond to it, the particular players who are involved may be different.
Okay.
If the power goes out, then clearly the power company is involved, right? If it's a wildfire, that may be a different set of players, a different set of resources.
Cool. So in understanding critical infrastructure and connectedness, the second part of the connected communities piece, I know that there are many initiatives around connected communities and the challenges of one, connecting communities, and then two, the question of where is that technology component that describes connectedness? How does that dovetail into the information space, the data space, the awareness space, the situational awareness space, if you will? Where is that? What kinds of technologies are we talking about, and what does smart mean in that context?
Yeah, so I think initially when you talk about connectedness, everybody thinks about broadband. Okay, so can I get high-speed internet? Can I get 5G? And there's certainly a communication component to the connectedness, but I think increasingly we are talking about data, situational data, what's going on in the world around us. And sharing that data, doing analytics on it.
Right.
Certainly, as we start to think about artificial intelligence and how that fits in, right? The how we understand the data that's flowing from what can now be millions of IoT devices, connected devices in our environment. So and then you additionally think about now control systems. So how do I control the traffic lights in my town? How do I, the power plant that's providing energy, what's going on with that? Certainly we all rely on our phones. So what's the phone system doing in response to it? And these days, all of those control systems are online, are connected as well as the actual devices. And I think therein lies both the value that we're seeing, just an explosion in the amount of understanding that we can have of situations around us, but also some of the risks that are associated with that. And certainly, as we think about cybersecurity, right? That's
I find it fascinating when we talk about smart communities, smart cities, and smart technologies. When I think of smart communities, smart cities, I think of in the first instance, smart to me means self-aware, and in the second instance, knowing how to respond, and framing that response. You've been working on building these public data infrastructure kinds of initiatives where we can share data and collaborate across multiple organizations in an effective way. When I think of AI, and there we have a whole new layer of vulnerability and challenge, and also potential value and benefit. How do you see that playing out in terms of information sharing, data sharing, sharing of analytics, sharing of response models, that sort of management problem that's a shared governance challenge, and this new challenge that AI represents in terms of understanding both use and risk?
Yeah. So let's hold for just a moment on the artificial intelligence piece, because I think there are, even without that, there are plenty of challenges around information sharing, right? So if you think of say a hurricane. We use this example a lot of times. If a hurricane comes up in our area, the response will certainly involve police and fire and the emergency management services, but it also involve private sector. So where is the plywood? Where are the open hotel rooms? Where that people can evacuate to? Where are the medical facilities that are still open? And those private entities may be willing to share some of that information in particular areas for a particular period of time. When the event's over, they don't want to make that public. They don't want to continue sharing, right? And so I think the first component there is how do you selectively do information sharing? How do you share information with the people in the time and places that you want, but then be able to stop that when the situation no longer
just in time and on demand.
Yes, I think
just
so.
for just for that time.
Yes,
right. Locality based and temporally based in terms of how you share.
And now, secondly, now when we talk about IoT devices, right? I mean, by their very nature, they're distributed. They're very large numbers of devices providing information, whether it's within a critical infrastructure component, or whether it's environmental information. Increasingly, we're using sensors to understand the airspace, what are drones flying, or helicopters, right, that kind of thing. So how do you kind of integrate all that information and do it securely? So that's now step two, is how do I learn to trust the information that I'm seeing? And one approach that we've used now is, at least here in Virginia, the local government is kind of uniquely positioned to be the authoritative source of data for certain types of data. Right. So when we talk about emergency response, we have a Department of Emergency Management. They are the authoritative source of data. Lots of other people can be providing data into the system. It's up to me, whether I believe it or trust it or act on it. But I know where I can go, at least for the best available current data. So that understanding, now we've talked about the devices, are they the devices I think they are? Who's aggregating that data? Who's providing it? And how do I use it for a defined period of time? And now you want to throw AI into the
well, yeah, there you go. So in staying on that sort of device view into things, with just the sheer number of sensors that are out there, both in terms of types of sensors, the numbers of each type of sensor, the sort of diversity of how they're managed and supported, how that data is aggregated, where it's aggregated, a lot of that being done by private companies, not public entities. Right. So there's this immediate dependency. I had one of my colleagues from the campus side, one of the universities, tell me that the first time his eyes were really open to the challenge was when the folks in facilities came to him and asked him how they might hook up the windows that they just installed to the Wi-Fi system. And he was going, what the heck is that all about? I mean, come on. It's just not like I didn't have enough headaches as it is. So we've got all of these things that are happening. I mean, you can't buy an appliance today and not have some kind of technology embedded in it. Right. If you drive in a car, it's got 3,000, 4,000 components in it, all of which are connected in some fashion. Yeah. As we get into that side of things, the trustworthiness of data depends on the trustworthiness of the device. Mm-hmm. And it depends on the pathway in which, that communication path, how is that data conveyed? Has it been interrupted? Has something been interjected into it? Could you talk a little bit about the risks and the downside issues that are associated with this proliferation of devices within the ecosystem at large? Because in a sense, as I've watched CISA go from describing, a few sectors of the economy as being part of critical infrastructure to pretty much saying, well, everything's critical infrastructure, at some point. So talk a little bit about that that vulnerability, that risk set, those sets of risk vulnerabilities that we have, and how we can begin to think about mitigating those.
Yeah, so I think most people are familiar at this point. We've seen enough examples of critical infrastructure and the control systems being online and being vulnerable to people taking control of the systems, whether it's from autonomous vehicles being driven off the road, or power plants, or dams, electrical grid, all have been challenged, if you will, because of their control systems are online. So I think that's one thing. It's clearly critically important. Certainly, when we talk about protecting critical infrastructure, there's that trade-off between ease of control and management of complex systems and the risk surface that presents. I think increasingly, and here I'll sneak a little bit of AI back into the conversation. Just recently we've been seeing a pretty significant uptick in the amount of financial fraud by people being directly in the middle of transactions. Well, I say people, but hostile entities, if you will, being directly in the middle of financial
malicious
transactions. Right. And actually, when I was coming here this morning, on the radio was a story about a local volunteer fire department who thought they were, transferring funds to buy a new ambulance, and it turned out that they were transferring funds for some malicious actor's yacht, I suppose.
Someplace
instead.
Yeah, right.
Significant financial impact to the entity, to the community, to the services they're able to provide going forward. And then I think there's a third concern that's lurking out there, if you will, and that's sort of the threats from hostile nation states are I think becoming increasingly there in the background. Certainly,
it's not just a lone person trying to take advantage of the system for malicious reasons or just for the fun of it. We're now into systemic kinds of attacks, and persistent attacks. So
national security implications.
It becomes national security.
Yeah.
And since every vulnerability is a backdoor to some system, which may interconnect with other systems, you run into that. You run into that kind of problem.
Sure.
You mentioned AI, and I want to maybe dive a little deeper on that. If we're talking about smart, we're talking about self-aware and responsive. And the IoT technologies are both sensors, but also actuators. They can act. And in many cases, it's useful to have AI in the mix because it increases your response capabilities, both in terms of responsiveness, time delays in responding, and effectiveness of response. Talk a little bit about how training those AI components, those technologies, and bringing them into this ecosystem, which can obviously be very helpful if managed properly. What kind of vulnerability does it create in terms of creating false sense of reality and how that impacts things? The example you just gave is one good example of how if that wasn't a person but an AI that was misbehaving, that could be a massive problem.
Yeah. Well, so and this is a very rapidly evolving area, and I think it's actually been kind of interesting to watch. At least the policy community, the governmental, the federal authorities, and so forth, are actually working pretty hard to try to not be too far behind the the leading edge, as opposed to what we saw when the internet first came on. It was 10 to 15 years before people finally caught on.
Much less spell internet.
Right. So I think part of the concern is that AI systems tend to be black boxes.
Right.
Their behavior is hard to characterize, and you mentioned the training data. So it's not only is it hard to characterize, but it's very heavily dependent on the set of data that that system was trained against. I think that clearly introduces a number of risks. Certainly the sci-fi World has had a field day for decades now, predicting that, AI-based systems will eventually decide that humans are expendable.
But Skynet, yeah. That's
But
Matrix, Skynet,
right. But closer to home,
Yeah.
the manipulation of those systems, I think does introduce a number of vulnerabilities. The speed of action of those systems. So if we talk on the cybersecurity side, certainly the community is coming around to AI-based systems are what you want to use to mitigate attacks from AI-based systems. The ability to rapidly recognize patterns, the ability to make a selection among a set of choices and take the most appropriate actions much faster than humans could ever think about.
Which means they can run ahead of us.
Yes, right.
In the wrong direction.
Yes. Now there's some other risks as well. There's some well-documented cases of either inherent bias built into systems that people kind of didn't think about ahead of time. Poisoning of systems where over time they're,
right.
Certainly if you look at AI-based systems that are turned loose on the body of information from the open internet, they very quickly start taking more extreme positions on various issues, that type of thing. So there I think a number of concerns as this technology evolves rapidly. As this risk perspective, we're certainly in the business of trying to bring those technologies into the ecosystem, into the communities that we're working with. And I think initially we're looking at, are there ways to kind of constrain the behavior of those systems so that no matter on what basis it's reaching the outcomes of the decisions that a system is making, we know it's only going to choose between these 10 acceptable things as one of those outcomes.
How do just you've referred to your initiatives in smart communities as living laboratories.
Yeah.
These experiments at scale, at small scale,
Yeah.
But with sufficient complexity to understand a technology and its implications.
Right.
How important is that in your mind as we begin to look towards, achieving some of the benefits and meeting some of the expectations of benefits that these technologies provide, both from the IoT side and the AI plus IoT side of things, but doing so in a manner that isolates them enough initially so that we can understand the downsides and mitigate those risks. How have some of these initiatives helped? You've got a number of them across the state and beyond.
So first of all, when I talk about a living laboratory, right, I mean, kind of the definition that I use is it's actually an operational place. For example, we've worked extensively with the city of Winchester in Virginia. So it's an operational place that's willing to host some of these experiments that you're talking about. And there's a lot to do with how you define the experiment, the boundaries of the experiment, so that you kind of minimize the risk. I see the process as also how you enable adoption of technologies. So if you look at, say, a university research laboratory, right, the people involved with the technology are the researchers, not necessarily the people who are going to end up using the technology in practice. So we like to.
Look, who designed this car? It wasn't a mechanic.
Yeah. So we like to get the end user community involved, actually in the design and in the evolution of a design from an early prototype to a functional thing, because they're the ones who know how they're going to use it, right, on a day-to-day basis. And then from a living laboratory perspective, the first thing you need to do is demonstrate that a technology can do the things it claims it can do. So,
right.
So if your claim is that this sensor can provide early indication of a wildfire ignition, okay, we've done laboratory tests. You light a fire near it and you blow smoke in that direction. sure
See
enough,
whether
it can
picks it up,
detect.
right.
Now let's put it out in the field where there's diesel, there's cars and there's backyard barbecues, and let's see that it can do what it claims in the actual environment. And then, to my mind, the second thing is, once you've done that, yeah, it does what it says it's going to do. The second question is, where does it break, right? And so, what are kind of the boundary conditions around when you can use that capability, when you can trust it, right? I mean, if a sensor starts putting out a string of all zeros, does that mean that the sensor's broken? Does that mean that what it's sensing is down to such a low level it can't detect it anymore? Be good to know, right?
It'd be good to know. It'd be good to know. So getting into the trust issue, we've talked a lot about it otherwise. The NIST framing and sort of the CISA maturity model associated, that sort of aligned with it, speaks to various ways of establishing trust, end user trust, device trust, communication trust, data and application trust. And I know you're fond of adding AI trust in the mix. As you think about the building blocks for putting that together, where do you see that IoT device trust in terms of priority? I know from working within the communities of practice that, end user trust is something that people are working on, multi-factor authentication and authorization kind of protocols. And then network security has been an issue with firewalls, and that's been evolving for a long time. I'd like to get your thoughts on that device trust aspect of things. In particular, in part because, this is a conversation in part about IoT and the role that Keyscaler and products like it help us measure and deal with device trust. So if you could talk about the importance of device here.
Yeah, and to me, the fundamental thing is that we're really seeing a radical shift out of sort of controlled and closed enterprise networks into the cloud and distributed environment where we really don't have control over what plugs in on the other side, right? And so knowing who that is or what device that is fundamental to the whole issue of trust, right? If I don't have some understanding of what's out there on the edge of my network, whether it's a sensor, whether it's a laptop, whatever it is, whether it's a complex system, to some extent, nothing else matters, right?
Right.
Because now anybody can come along and put a rogue device on on my enterprise. On the IT side, we live. My VIPC lives in a hybrid environment where many of the devices are provided by sort of a central IT function that does quite well in terms of controlling and protecting those devices. Right. But then there's a whole other set of bring your own device, people using different devices to access those same services. And so, that's got to be the starting point is understanding what's out there at the edge of my network. Then you can start building the rest. Then you can say, okay, now is it getting to me securely? Right.
Right.
There's the communication piece of that. Once it gets into the point where I'm aggregating that data, can I do that securely? Or if I'm have a set of functions that control access to my data, can I protect that well enough in a computing environment that's not a target, or that much less a target for people to attack. So if that were the extent of it, life would be easy if it weren't for all those dang users, Yeah.
It is a challenge in the sense of balancing human and artificial and intelligence and capability in the mix. As much as there's hype around the use of AI, generative AI, in a lot of places, and it's a necessity in certain contexts because we just can't, as humans, respond fast enough and at scale to the many ways in which things could go wrong. The question is, where's the human side of this? As VIPC, you're responsible for economic development, generally writ, not just on the innovation side of things, but also the application side of things.
Sure.
And when we get to the application side of things, where do you think we are on the human capital development side of it, if you will, in terms of having a workforce that understands what these technologies are capable of, so that we can effectively manage that?
Yeah. So, if you project forward, where do we see the role of people, right? I mean, we've already spoken a bit about analytics and AI-driven analytics, and so, I think it seems clear that people are becoming further removed, if you will, from the raw data. We talk about, as an analogy, understanding how a computer works, right? I mean,
right.
When I started my career, I could tell you
exactly how it works,
exactly where all the bits and bytes were flowing. Now it's right, and so I think as we move into increasingly complex information environments and operational environments, having people, first of all, from just an operating point of view, having people who still know how the computer works, who still know how the sensor works, what is that sensor doing, who still have some clue as to when an AI-based system performs some set of analytics, what's it actually doing in there, and can I understand the
understanding the algorithms?
Right. I would hope, I would expect, certainly in my lifetime, that people would still end up being the decision authorities. What do you do? But even there, we've already talked about intelligent systems as actuators and being able to respond to cybersecurity attacks much more quickly. So I think in kind of the intermediate term, it's how are we going to build those controls into the system that will provide some kind of assurance that they'll continue to operate, within the context that we want, within the parameters that we set for those critical systems.
So one side of the human side of this equation is policy and regulation.
Yeah.
Standards, policy, regulation, sort of that governance overall kind of conversation. Where do you see, at least for the U.S., in terms of what you know from Virginia and more broadly, where do you see policy going? Where do you see the mandate going? A lot of folks in smaller organizations and institutions see a lot of the sort of zero trust obligations that are being put on them as being unfunded mandates and challenging. Most new technologies, when they're brought into at this kind of scale, are going to have that feel to them.
Yeah.
How do you see that balance evolving over the next, 2, 3, 5 years?
Well, I think in that kind of time frame, the next 2, 3, 5 years, that the market's going to start demanding sort of integrated security at some level in the devices, right? I mean, we've certainly seen some of that even on the internet, and that kind of thing. I think it's still quite possible to do that in the IoT space.
Okay.
For example, Keyscale or device authority, right? I mean, the ability to tag devices at scale autonomously, to be able to understand the signature of each individual device, even when you have millions of them, right? I mean, and the ability to manage those that complex of devices and what kind of access they have to your enterprise resources. So, I think that's important from a policy point of view. right now there's a lot of activity around what, for example, with AI systems, what is going to be allowed on various enterprise networks. My guess is that's probably over the longer term is probably a losing battle, right?
I think they usually are.
Right. I mean, as society gets more and more comfortable with a set of capabilities, there's always somebody pushing that edge, of what's the next set of things. But I think it's important to understand what, kind of what those control features are, what those guardrails are, if you will. Eventually I kind of come back to the ethics or the philosophy or the laws of robotics, if you will, right? Back in early science fiction, right?
Thank you, Osmo.
Yeah.
Gave us a starting point for this problem.
Kind of how are we going to allow systems to operate in the context of a human society? And I think we're struggling with that right now, for example, in social networks, right? I mean,
right.
We've seen the benefits of, hey, I can pick my college roommate ahead of time, way back in the early days to now, the online bullying and that whole set of behaviors, disinformation and so forth. And so how do you evolve a set of ethical principles that are socially agreeable, right? I mean, I'll give you one example, right? I mean, there's always this discussion around First Amendment, means I can say anything I want to say, right? And I go back and look at that and say, well, that was designed for the public square when somebody could stand up and say, here's what I believe, and not be found guilty on that basis. But what we're seeing now is anonymity rather than freedom, right?
Sure,
I mean, so the ability to stand up and say things that people might object to, but have it not be attributable to any person.
Right. To just kind of bring it home, I think here, as you look towards this balance of living laboratories, experimental stuff, and then actual deployment and engagement. We've done a lot of good things in terms of understanding new technologies, and there are a lot of these initiatives out there. The question becomes, at what point do you start injecting real technology into the real fabric of communities and having it work? There is, if we can't get past the security issue, we're not going to get past the blockers to collaboration. And without those collaborations, both in terms of kinds of data that we're getting from sensors, from each other, from agencies, there's a lot we leave on the table in terms of value and benefit. How mature do you see us now from where your vantage point, where the rubber meets the road, if you will, in terms of, are we 2 or 3 years away? Are we further away from really being able to approach in a mature and healthy way the application of these technologies?
So I think in many of the technologies that we work with, the technologies are pretty much mature enough to at least get first fielding. I mean, obviously they'll evolve as they're out there.
Right.
I think some of the limiting factor has to do with people's acceptance of risk, and so we've become very litigious, very bureaucratic as a society, and so almost to the point of being immobilized. Let me give you 2 examples. One on the maturity side, and then one on the risk avoidance side. So, unfortunately, not very long ago, there were some significant wildfires in Hawaii and Maui, and there were, some people were killed and a lot of property damage. And so when we go back and
it wasn't lasers from space.
no, well, not to my knowledge.
Or you won't admit it if you knew.
But the sensors, we think we have mature sensors now. And we're deploying some of those in Hawaii in that setting. That we could, the systems have improved a full generation that we can now detect in significant ways wildfires and provide early warning. Now, you have to be careful because if you have false alarms, people are going to start ignoring it, right? And so when you hit the point where you're comfortable enough that you can send out a warning. Second question is, what do you put in that kind of warning? What do you tell people to do, right? It's not enough to say there's a wildfire in the area, you better run like heck, as opposed to saying there's a wildfire that's approaching you from this direction. Here are some roads that are open. The nearest emergency shelter is over there. With
the more complex information environment.
So pack up and leave in the next 10 minutes. Right. And so that level of maturity, I think, is still a little further off.
Okay.
So now let me give you a sort of the counter example, the risk averse counter example. We've done some experiments where, we've provided sensors that can give warnings of threats in a building environment, right? In an office building or something like that. And from an ownership of the facility point of view, if I know something's happening, so I get a warning that something's happening, maybe there's an active shooter.
Right.
And I don't do anything about it, I'm legally liable for that at that point. And so, there's some situations where even though the capability is there, I'd rather not know because
I ran into that actually a little over a decade ago on putting, do you put video cameras in parking lots?
Right. So
does it make you responsible if you're not monitoring continuously?
Yeah. And so, I think we've gotten off track a bit as a society, in terms of what's acceptable and where's value, even though it comes with potential downsides, right? I don't know how to fix society. I mean, I'm a technologist.
Devices are a whole lot easier to manage, as Keith Scaler will tell you, and John will attest to. He has an easier time with devices, I think. Yeah. I think, John, right?
Without a doubt.
Thank you. Well, David, this has been a fun conversation to have. Thank you very much for that.
Yeah.
And enjoyed it, and let's do it again sometime.
Yeah, likewise. Maybe we'll figure out how to address this people thing before long.
Maybe. Just install a device. Yeah. I think someone famous is thinking about putting chips in people's heads. Right. We'll figure it out from there. John, back to you.
Gentlemen, thank you so much for that conversation. I really enjoy listening and learning to people that know what's going on, and it was very well rounded. I really appreciate the timely examples. I mean, every one of those has been in the headlines or in some technology form very recently in our world. At this point, we'd like to open up for questions and see what our audience would like to hear about.
All right. Look forward to it.
All right, so let's go on to questions.
Yeah.
Well, hi, folks. It's Khalil. As you probably figured out, Dave and I had to pre-record that session. We had some unavoidable conflicts with respect to this time slot for today, but we did want to have a fun little conversation to explore some of the challenges of bringing IoT into the connected community context. So I'm sort of pitching in here. Dave was going to try to connect in, ran into some technical difficulties as we've experienced with other presenters. So I'm here to answer your questions. I have three here already in the queue. The first one is, as communities become more connected, does it mean that there's a higher risk of data breach? And then a corollary to that, I think a bit complementary is, there's the question is IoT devices are about 50 to 1 over non-IoT devices. How are we addressing IoT security at this scale? I think they're kind of connected questions. When we think about the risks, they are exponentially growing. And they're growing in more complex ways as the technologies begin to evolve even further. In the first instance, if you've got a device, a smart device, something attached to your refrigerator or windows, or a component in something simple that's operating in a simple way, the complexities of securing it are going to become at least isolated or isolatable. You can control them and contain them in a meaningful way to whatever that sensor, actuator, or feedback cycle might play out as. Once you start interacting between and among these devices, as you've heard in some of the previous sessions, in connected vehicles and in the thousands of components that are in any given vehicle, and you begin to think about how that interaction of connected devices, which are getting updates at different schedules, and the complexities that creates from a security perspective, you start to appreciate that, this is not going to be a simple exercise anymore, and we need to be thinking in more profound ways about what the consequences of deploying these technologies are. And in that sense, as communities become more complex, so you sort of extrapolate from, say, a connected vehicle to a connected community or a set of communities, and you start adding human actors in the mix of the IoT sensor to actuator augmented by AI kind of scenario. And there's a lot of opportunity now to have this complexity turn into a challenging problem from a management perspective and from a delivery of services perspective. So I think as we begin to think about how to do all of this, and I'll fold in the next question, which is it hard to get the private sector device makers to adhere to new government expectations for security? You start to think about, we can't live with unfunded mandates, and we can't live with a tsunami of change that we haven't had some degree of control over, or at least some understanding and appreciation of. And I think on this last point, what Dave talked about in terms of what VIPC and his groups are doing in terms of living laboratories is really quite important for us to keep in mind, because it gives us an opportunity to evaluate technologies and their impact and their interaction in controlled environments before we let them loose within the larger communities that we're trying to support and bring the benefits of all this technology to. So it's in my mind, and I think David would agree if he were here, the necessity of understanding technology and making a reasonable self-critical evaluation of how well we understand them, and how well they impact us, and how they interact, is something that's quite essential to the application of security to these technologies, so that we can get their benefits without the downsides. We have another question now. It just came through. Is how does CISOs see their role evolving to pay attention to IoT device infrastructure, not just IT network infrastructure? I don't want to speak for my CISO colleagues, although I was at a conference. I stayed at a Motel 6, so I know I talk about IT security and IoT security. I think my fellow CISOs, which I'm not one, but play one on TV, they have a hard time understanding where they're going to go with all this. They are working on it. It's been an ongoing question for at least a decade for them. The first time I had one of my university colleagues, IT colleagues, bring this up was when he described what happened when they brought smart trash cans on campus. And the first thing they realized was, oh, wow, this is great. We've reduced the number of trips that we have to make to empty trash cans by 65%. Big gain. Need fewer people, fewer trips, less gas, etc. And everything was great until they had a DDoS attack, denial of service attack, originate from one of those sensors on the trash cans. So, and that's been around for a while. As we start to layer these complexities in, the challenge that CISOs are going to face is they need to understand not only the sort of technology approaches, technical approaches to securing the environment, but they've got to be able to talk to device manufacturers. They've got to be able to talk to device manufacturers about how those technologies can be secured. They have to understand what those devices are going to do, how they're going to act in the environment, and establish requirements for how they want to integrate them into what would be otherwise somewhat unique environments. As we're going from a sort of legacy OT-based environment to a richer, interconnected, smart device kind of an environment, you have to factor in the fact, the reality that the starting point for any setting, whether it's an industrial control setting in the traditional sense, or it's an airport, an emergency response ecosystem, they come from somewhere, and they've got established practices and established technologies. And as you introduce new technologies, the question becomes, do we know how to really interconnect them in a secure way? And by bringing IoT devices in an environment, am I increasing my vulnerability, the landscape that makes me vulnerable in a way that I don't even recognize and understand? So part of our large challenge is, how do we work together in a productive way to understand the vulnerabilities, understand the risks, and convince device manufacturers who are oriented towards profit maximization, who are worried about costs, who don't want to engage in development where it's an unfunded mandate, where there's a regulation, whether it's an executive order or a NIST requirement or a CISA requirement. How do they deal with unfunded mandates? How do we pay for all of this? And what kind of friction does it create in adoption and deployment as we begin to put some of these requirements in place on infrastructure components that are driven by intelligent devices and connect together? The other part of the challenge that I just want to point out to the audience that we absolutely have to address is the interconnectedness that we are now having to face in a very real way. It's not just the fact that we've got a lot of devices; it's the fact that we are interdependent in terms of the influence and consequences of deploying all of those devices, and in terms of seeing the benefits from those devices, having a secure, trustworthy basis to share data, to exchange analytics, to train AI in a meaningful way, is a value add that we can't get to if we can't secure the devices themselves. And as I'm sure you've heard multiple times here in these sessions, if you can't secure the device, you can't trust the data. If you can't trust the data, you can't trust the AI that's built on top of that data. And as we continue to build data environments and analytics and AI on top of an ecosystem of IoT devices that may or may not be secure, of interactions between and among agencies in exchanging data between and among the private sector, commercial entities, and the public sector when it comes to things like emergency response. We're gonna be challenged by that. And so, we mentioned during the conversation with Dave that, at this point, CISA is basically saying everything's critical infrastructure. The solution pathway really has to be a community engagement. It has to be something that we do together. And we have to find ways in which to do that without imposing requirements that people can't really meet and creating unfunded mandates unnecessarily. So with that, I don't see any other questions coming up. I think, I hope that the audience got something out of the conversation. Dave is always wonderful to talk to. We're both reachable, so if you need to get a hold of us and have any questions of us, more than happy to engage. And if you're looking for advice as to how to build these living laboratories and communities of practice around exploring how technology impacts us, Dave's a great resource. Thank you, everyone.